This is to give you a brief introduction to what is a quadratic and, just as importantly, what is a parabola. Now, these two things are very closely entwined as an idea. If you look over here, we've got y equals x squared. Now, that is a quadratic function. It is something that plots y given an x value. You may sometimes see it written as f of x, and there is no difference between f of x and y. What does this actually mean in terms of the graph? Well, it means that when you plot the point 0, you square it, and the y coordinate is also 0. The x coordinate is 1, so you square it. 1 times 1, 1. The y coordinate is also 1. And you might think, well, surely that pattern is going to continue. 2, you're going to get the point of 2. But remember that we're squaring. So when we have an x coordinate of 2, what is 2 squared? 4. So our y coordinate is 4. Let's zoom out a wee bit more. What do we think it's going to be for the coordinate 5? Are we going to just get it in? 5 squared, the y coordinate is 25. And what you'll be able to see is very quickly the numbers on the y-axis start to increase. So we're barely past the 10 mark, but our y coordinate is already past 100. Now, normally you'll just be shown a graph that looks something like this. And from there are certain things you're asked to identify. You're asked to identify what we call the turning point. Now, in this parabola, the turning point is 0, 0. That is where our graph changes direction. You're also asked to find the roots. Now, in your basic quadratic and the parabola, it touches the x-axis only once. And again, the roots of this parabola are at 0, 0. You're also asked to find where you cross the y-axis. And the same as with straight lines, we call this our y-intercept. And again, where do we cross the y-axis? We cross at 0, 0. So the roots, the y-intercept, and the turning point are all 0, 0. What's of interest? What about the equation of the axis of symmetry? Now, this is going to be a straight line equation, and you've got to think, if you folded this parabola in half, at what x value would you be folding it? And it would be getting folded at x equals 0. So if I plot that, x equals 0, you'll see we have a straight line vertically cutting our parabola into two identical symmetrical halves. And that's such an important thing about your parabola, is because you're squaring, your positive values end up the same as your negative values, giving you that symmetry. So we've got the roots, we've got the turning point, we've got the axis of symmetry, and we have the y-intercept. The very last thing that we're interested in when we see these parabolas are whether they have a maximum or a minimum turning point. And this determines the nature of the parabola. Here we have a happy face, happy smile. This means it is a positive parabola and that it has a minimum turning point, because the smallest point this parabola will ever be is its turning point. To give you an example of what a negative parabola is and having a maximum turning point, all you have to do is, instead of having a positive x squared, you have a negative x squared. And that entire graph will flip the other way. And now this is a maximum because it is the biggest value, the most positive value that parabola will ever be is at 0, 0. So in general, f of x equals x squared is quite a boring parabola. There's not much of interest about it. But don't worry, there's millions of different versions of these, infinite versions. And all it takes to find another one is to make a trinomial. There we go. We have another parabola. Here, we can see our turning point is going to be different from our roots, and it's going to be different from where we cross the y-axis. What are they? Well, your turning point is right at the bottom there. So your turning point is negative 1.5, negative 4.25. Your y-intercept, now this is important, your y-intercept is a coordinate, 0, negative 2. And what are our roots? This will be a decimal approximation. It's probably got some thirds and in there that are meaning this is a decimal that go on and on and on. But for the gist, they are crossing approximately negative 3.562 and positive 0.562. So those are your roots. Lastly, we've got to think about that axis of symmetry. Now that axis of symmetry will be going through the x coordinate of your turning point. So x will equal, you look at your turning point, negative 1.5, and that is your axis of symmetry. So again, we have our axis of symmetry, we have our turning point, our y-intercept, and our two roots. What is the nature of this graph? Well, this graph is positive because it's a smiley face, and that means it has a minimum turning point.